This question is to compute the integral cosine z over z times z squared plus 8 dz over the contour shown here. So as you can see in this question, we are given the function, we are also given the contour. However, we notice that it is very difficult for us to find the antiderivative of the given function because we have the cosine z in the numerator part. We also have the z squared plus 8 in the denominator part. So in this case, we know we're going to use some other method to help us compute the integral. So we know there is a theorem like this. Let f function be analytic everywhere inside and on a simple closed contour C taken in the positive sense. And if z0 is any point interior to C, then we have f z0 equals 1 over 2 pi I times integral f z dz over z minus z0. So comparing the integral function in the theorem and the one we are given, we know the key point to use the theorem is that, of course, first of all, we need to make sure the given contour is a simple closed contour taken in the positive direction. And then the key point is that we need to find the appropriate point z0, which is interior to the contour C. And we also need to find the corresponding fz function based on the given integral function. Okay, so now let's take a look at our question. We know from the denominator part z times z squared plus 8, we know z0 should be the origin 0, 0, which is interior to this contour. And of course, the corresponding fz function should be cosine z over z squared plus 8. Okay, and we know the z0 point is inside the contour C and the fz function is analytic inside and on the contour C. So all conditions are satisfied, therefore we can use the theorem. So the integral function in the theorem fz dz over z minus z0 can be rewritten as integral. We just need to substitute cosine z over z squared plus 8 over z minus z0, which is 0. And from the theorem, we know this function equals 2 pi I times fz0. And we just need to substitute again using the z0 value, which is 0, 0. It becomes 2 pi I times cosine 0 over 0 plus 8. So just simple math, which is 2 pi I times 1 over 8. Therefore, the final answer is pi I over 4. So next time when we see this a similar question, we are given the very complicated integral function and the contour, and we have noticed it is difficult for us to find the antiderivative of the function. We know we can use some theorem to help us to solve the questions.